Our next presenter, Mr. Cenk DEMI RKIR.
Yeah, I am here. Okay, I'm going to start.
You continue. Right.
Hello, everyone. My name is Cenk DEMI RKIR from Karadeniz Technical University. I'm going to talk about the effects of wood species, nail size, grain direction, and layer numbers on lateral nail strength of structural plywood panels. As you know, solid wood and wood-based composite boards are used in buildings because of their excellent advantages such as easy processability, low price, good aesthetic appearance, and lightweight. Plywood is one of the most common wood-based panels, has many usage areas, varied from furniture to construction industry. Plywood is also one of the best sheeting materials used in the shear walls for resisting earthquake loads because they are able to tolerate the greatest amount of displacement before failing. A shear wall has two structural functions, lateral strength and stiffness. A shear wall must provide the necessary lateral strength to resist horizontal forces such as wind or earthquake. In general, the strength, stability, and life of structure largely depend on the strength, rigidity, and durability of the joints. The stiffness of a shear wall depends on the combined stiffness of its three components: lumber, sheeting, and fasteners. One prime advantage of wood as a structural material is the ease with which wood structural parts can be joined together with a wide variety of fastenings, nails, spikes, screws, bolts, lag screws, drift pins, staples, and metal connectors of various types. When walls are covered with structural wood panels, fasteners play an important role in strength and stiffness of structure. Is that the lateral nail resistance test are carried out in order to determine the joint performance. Fastener's performance can be affected from many factors, such as fastener properties, wood properties, connection types, and fluid application conditions. The aim of the study is to determine the effects of wood species, nail size, grain direction, and layer numbers on lateral nail strength of structural plywood panels. In the study, Scotch pine, black pine, and spruce were used. The logs were steamed for 16 hours before veneer production. Rotary cut veneer sheets with dimensions as you can see. After rotary peeling, the veneer sheets were oven dried. 5 and 7 ply plywood panels were manufactured by using phenolformaldehyde glue resin with 47% solid content. The assembled samples were pressed in a hot press. The lateral nail strength test was conducted according to ASTM D1761. Lateral nail connection specimens were made with nails driven. The nails were driven pneumatically to connect the framing member and sheeting material. Spruce timber was used as the primary member. The size of the sheeting member, you can see. The specimens were oriented so that the load was applied parallel and perpendicular to the grain of the main axis of plywood panel during the test. Also, nail size were chosen as 60 and 80 common nails. load was applied parallel to the grain of the framing material during the test. The movement of the specimen under load was constrained to one direction. Here you can see we got the highest values from lateral strength from Scots pine as wood species. Also, we got the highest values from 7-ply plywood panels as layer numbers. As grain direction, we got the highest values perpendicular grain direction, and from 80 common nails gave the high results as nail size. The following properties were calculated from this test. Initial stiffness, maximum load, ultimate load were obtained from this figure. Here we can see the stiffness values obtained from the test groups. You can see the highest stiffness value that obtained from the 7-ply Scots pine plywood panels with the 80 common nails in perpendicular grain direction. This stiffness is also the most important parameter in this test. I have just summarized these conclusions during my presentation, so next. Thank you very much for your attention.
Thank you, Cenk, for this nice presentation. And I see that there are no questions. I'm looking at it. Okay, there I see one question there asked by the Turgay Özdemir. Can you see the question, Cenk?
Yeah.
And I can read it if you want it. Can you explain nail test results about 5 and 7 plywood differences? Like 5 and 7 layer of plywood differences.
Yeah, okay. 5 and 7 plywood panels were manufactured in this study. But I think someone shared his screen.
I guess they put the first one. I guess second presentation they put it up.
Okay. You can see my screen.
Yeah, I see it now. I guess your results show that the 7 ply was better than the 5.
Yeah,
Yes,
7 plywood panels is better than 5 plywood panels because of these results get obtained from the 7 plywood panels because of the nail have to come across to more thicker ply. Yeah, this is the answer of the question, I think.
Okay. Right. Thank you, Cenk.